Okay, so today we are going to talk about some of the basic concept of sets. Okay, uh, so let's define a set. What is a set? Set is nothing but a collection of objects. Okay, so let's say you have apples, pencils, books. So those things are a set of. Let's say A is a set of yellow oranges. Okay, B is a set of blue oranges. Although I don't know if blue oranges are there or not. Let's assume it's there. C is a set of black orange. Yeah, I know. Just for the learning purpose. So it's nothing but a group of, or instead of, you can also say it collection of. Okay, collection of objects. And in maths, how we represent set? Inside this parenthesis. Okay, you can write anything. Let's say you write apple 1, apple 2, apple 3. That will be a set. So now, since we are talking about maths, let's focus on numbers. Okay, so let's say A is 1, 2, 3, B is 4, 3, 2, C is 8, 11, 13, 14, anything. Okay, any number. It can be negative number also, fraction also. So whatever you want. So let's take another example for the math. It's all natural number. Let's say you can call natural number is a set. Okay, all the natural numbers. B is all the non-negative numbers. Non-negative numbers is a set. Okay. And you can say C is another set, all irrational numbers. Anything, like, it's a group of objects. So these things are called element. For the definition, we learned of a group of objects. So now, when we are talking in terms of math, we'll call them elements for the to remember things in easier way. So these are the elements of A, or we can also call it member of A. So whatever you want to call it, element, member, an object of set A, whatever you want to call it, up to you. But let's focus on the word element or member. So I will use element or member. Now this is like, different type of sets, like natural number, non-negative, or all rational numbers. There is a thing called universal set. Universal set. Okay? How universal set is like, a set of everything. Here we define, this is an example. Let's take an example. We define A is a set of yellow oranges, B is a set of blue oranges, and C is a set of black oranges. So then we can say, okay, let's say U, we will use letter U as to represent a universal set. Okay, so U is set of all types of oranges. Okay. Okay, so you will have all A, all B, all C. So if there are 3 types of oranges in the world, okay, on this Earth, planet Earth, then you can call U is the universal set that contains all types of oranges: yellow oranges, blue oranges, and black oranges. Now let's think about maths. Here we define the natural number, non-negative number, or irrational number, or let's say D is also some all rational numbers. So we can define a universal set that is just all type of numbers, all types of numbers, okay? All numbers you can write. Doesn't matter. It's a rational, irrational, negative, positive, integer, fraction, anything. That's part of universal set. So universal set is like set containing everything. Let's say here in this example, all types of oranges. For this example, all types of numbers. It's up to you. You can also define a universal set. You can change the scope of universal set. You can call, okay, universal set is all positive numbers or positive integers. This can also be integers. And then you can say, okay, A is all the numbers, all positive integers. Let's call positive integers instead of numbers. Positive integers greater than 100. Something like that. It's up to you. You can define in any way. Okay, this is the basic definition of set and universal set. Basically, all these sets will be part of this universal set. Okay. Then there comes another concept called subset. Then you will understand it better. Okay. This is called subset. Subset is nothing but a part of bigger set. Let's take an example. Let's call A is 1, 2, 3, 4, 5, 6, 7. And then we have B is 3, 4, 5. So you see all the elements in B, they are from this set A. So in this case, A can be called a universal set. Even number of elements, how many numbers are 7? It's not like universal set will be very, very large. No. You can define any set as universal set and then remaining other sets smaller than that. So here C is, let's say 5, 6, 7. So these two B and C are subset of A. Okay? Understand? Okay. So what is the definition of subset? The elements of B, let's say B is a subset, then all the elements of B will be from this bigger set. Okay? Similarly, if C is a subset of A, then all the elements of C will be from the elements of A. Okay? Now tell me this thing. Say 6, 9, 10. Is this a subset of A? No, because it has 10 and 10 is not here. So some set will be subset of a bigger set only if all the elements are from the bigger set. Okay, if any element does not exist here, then this will not be a subset. Got it? So this is the condition. All the elements have to be there in the bigger set. Now think about this example. A is 1, 2, 3, 4, 5, 6, 7. Okay, and B is also 1, 2, 3, 4, 5, 6, 7. So is B a subset of A? Yes. Even if all the elements of B are in A, it will be a subset. Okay? Let's try this thing. 1, 2, 3, 7, 9, 10. Is this a subset? Another set here. No, because these two elements are extra. Now there comes another term. It's called proper subset. Proper subset. Proper subset. Just few minutes ago we learned that subset will have all the elements from the bigger set. Like here, B had all the elements from A. So B is a subset of A. But what is proper subset? In proper subset, the smallest set will have fewer number of elements compared to the bigger set. So let's see. C is 1, 2, 3, and 5. And D is this. Okay? And remove this guy now. So D is a subset of A because it has all the elements from A. C, it also has all the elements from A, but not all the elements are here. What are missing here? 4 is missing, 6, 7 are missing. So if it has all the elements from here, but it contains fewer number of elements compared to this, then C is a proper subset. Okay, this is the difference between set and subset. Now, proper subset, let's go through this one again. Subset can have all the elements, okay? Like here D. D has all the elements from A. But proper subset, it cannot have all the elements. It has to have fewer than the bigger set. Okay? So here C had fewer elements like 1, 2, 3, 4, 5, and it has 1 to 7. Okay? So now let's think about another example. E. Can it 1, 2, 3, 4, 5, 6. Is it a proper subset? E? Yes or no? Yes, because it does not have 7. If it has 7, then it's not a proper subset. At least one element should be missing from here, the smaller subset. Then only it will be proper subset. Otherwise, if all the elements are there, then it's a subset. Now you understood how many things? What is set? What is universal set? And what is subset? And what is proper subset? Basic concepts you understood. Okay? Do you need more example? It's clear. So, you can represent sets like this. Okay? This is A, this is B. Two sets. This is called Venn diagram. Okay? And then we are talking about universal set. This will be like all the elements from A and B. So you can write universal set. So this is the representation. What does it represent? It represents that A and B, they don't have anything in common. Yes or no? Because it's not overlapping. If it overlaps, it has something in common. Let's say A is 1, 2, 4. It has 8, 9, and 10. Okay? So if A has 1, 2, 4, B has 8, 9, 10, what do you think? What will be what are the elements in the universal set U? What elements are there in the universal set if A has 1, 2, 4 and B has 8, 9, 10? It's nothing. Both of them, some of them. Not some, like both elements from both the sets. Okay, so what do you think? It will be 1, 2, 4, 8, 9, 10. Because universal set, this universal set contains both A and B. That's why the elements of universal set will be all the elements from A and all the elements from B. So that's where the concept of union comes. Okay? So let's think about this. Union of sets. which is represented by U. Okay. So if A and B are two sets like 1, 2, 4, 8, 9, 10, the union of A, union B, you have to write like this. A, U sign for union, and B is all the elements from A and all the elements from B. And if there is some common, then you have to take that element once. I'm giving you that example also. So 1, 2, 4, 8, 9, 10. Okay. Now take another example here. This one. And then A here, B here. A, B. 1, 2, 3, 4 here, 6, 7, 8. So what do you see here? 4 is inside this circle B and inside circle A. So 4 is present in both A and B. How we can write here? 8, 1, 2, 3, 4. And B is 4, 6, 7, 8. Okay? Got it? This is what meaning of this representation. Okay? A has 1, 2, 3, 4. B has 4, 6, 7, 8. And 4 is common. So when you talk about this common element, this is called intersection. Okay? Intersection of sets. And this is represented by this symbol. Okay? Look at this symbol. Okay? So now what we are going to write here? A intersection B is equal to what? What is common between A and B? 4. Both has 4. A also has 4. B also has 4. So, got it? So, in union, when you are taking union of two sets, you have to take all the elements from set 1, all the elements from set 2, and make sure you are not repeating the same element. So, I cannot write like this. Let's say for this one, if you think about this, 1, 2, 3, 4, and B has 4, 6, 7, 8. Can you write like this? Since A has, as I told you, when you take the union, you take all the elements from A and all the elements from B. But condition is like, if there is some common element, write it once. So I will remove 1, 4. I will have just 1, 2, 3, 4, and 6, 7, 8. Okay? And this is called intersection, the common element between two sets. This is called the intersection. Okay, let's take some more example. Now I'm not going to draw the Venn diagram. So let's say A is 1, 2. Let's take another example. So you say, okay, A is always 10, 11, 12, 13, 15, 16. Okay, and B is 9, 10, 12, 18, and 20. Okay. So, what will be A union B? So, all the elements from A, let's write down. So, how you're going to, the easiest thing, how you're going to find A union B? First, write down all the elements from A. 10, 11, 12, 13, 15, 16. Okay? And then go through elements of B and see if you already wrote here. 9, no, so write down. 10 you already have. 12 you already have. 18 no, so write down there. Okay? This is simple way. Write down all the elements from A, and then when you are writing elements from B, just make sure this is not already there. Okay? So this is your A union B. Now A intersection B. What you have to do? You have to find which elements are common between A and B. So which elements are common? This one and then this one. Nothing else. 9 is not there. 18 is not there. 20 is not there. So this will be 10 and 12. Got it? Okay. No confusion in finding union and intersection. I'll take another example. Let's make sure we are talking about A is set of all let's say odd number. So 1, 3, 5, not all like up to 9. Okay, and B is set of all even numbers up to 10. 2, 4, 6, 8 and 10. So what will be A union B? I will write down. What did I tell you something a few minutes ago? Write down all the elements of A. First thing, okay? No, that will make life easier. Write down all the elements from A. So I will write down 1, 3, 5, 7, 9, and then I will go through the elements of B and see if they are already there. Since this is odd number and B has even numbers, do you think there will be any common? No. So I will just write down all the elements 2, 4, 6, 8 and 10. Okay. So this is union of A and B. What about A intersection B? Is there anything common between? So when there is nothing common, we use this symbol. Remember this symbol? This is called empty set. Empty set. Okay? You write O and a line. Or another way is this. This is also, because I told you this is used to write set, and then if there is no element, this is called empty set. This is also empty set. So if nothing is there, then it's empty set. So you can write A intersection B is empty set. In either way, like this way. If you prefer this one, you can use this one. I prefer this one because this shows that there is nothing in the set. Okay, so if you like this symbol, you can use this one, but my preference is this one. I think you understood the concept of union and intersection. Now we are going to talk about the inclusion and exclusion concept here. Okay. So let's talk about an example before, like the example is related to inclusion and exclusion. In a class, there are 20 students, okay? Inclusion and exclusion. Okay, there are 20 students. Out of 20 students, let's say 14 plays cricket, okay, and 16 plays baseball, okay. Yes. You say, okay, how it's possible? There are just 20 students. And you're saying 14 is playing cricket and 16 playing baseball. Is it possible? Yes, it's possible. What if some of the students play both the games? It's possible. Okay? And then if I say, okay, let's say 10 students play both. Okay, so here the concept of inclusion and exclusion comes. Okay, you saw this type of question in the, I think, the counting round, right? Asking like some students are playing some game, some students playing some other game, and some total number of students. What is the number of students playing both the games? So this is called the inclusion and exclusion. So let's first talk about the formula. This is an example I gave you. So this is your universal set, okay? Because all the students in the class, universal set, and this is the, let's call it A and call it B, and this is they play both. So when they play both, what symbol I should use? Union or intersection? Intersection. Intersection means it has to be in both. Union means it can be in any of them. Okay? That's what we learned a few minutes ago. Union means it can be either in A or B or in both. Intersection, it has to be in both. So here I am saying in both, it means it is A intersection B. Got it? So the formula is A union B. A union B means either in A or B or in both. Three things are there. Either in A or in B or in both. So that is A. This, you remember this sign? Size of or number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in both. Okay? This is the formula you have to remember. Again, let me repeat. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A and B. So let's take this example. Suppose number of students is not given. I have to find how many students are there. So what I will do? What is A? How many students are there? 14? 14 plus how many students are here? 16. And how many students are here? A intersection B? 10. So 14 plus 16, 30 minus 10, which is 20. Number of students in the class is 20. This is the formula, okay? Now let's take another example. Again, take another class. We don't know the, let's say we know the number of students. Let's say 50 students are there. 50 students, okay? And 35 students, they like pizza, okay? And 25 students, they like, let's say, taco. Okay? Now, can you tell me how many students they like both? So we have to use this formula. So let's call it A, students liking pizza, and B, students liking taco. Okay? So A union B is given 50 students. Okay? So and let's assume that other than these two options, all the students either they will like pizza or taco, nothing else. They will not like third food, just only one of these two foods. So that's why A union B is what? 50. Okay? So 50. Let's put the value. What is A's size of A? 35. What is size of B? 25. We have to find how many elements like both. Okay? So both means A intersection B side. So let's see. So 50 is equal to, this is 60 minus A intersection B. Okay? So 50 minus 60 is minus A intersection B. So this is minus 10 is equal to minus A intersection B, which means A intersection B is what? 10. Got it? So how many students like both? 10. Now if you get these type of questions, can you solve it in few seconds? Yeah, to use this formula, just A union B is equal to A plus B minus A intersection B. This is very simple. Okay? At your level, like middle school, I don't think they are going to use 3 sets, but we can talk about that. No? Okay. For this class, just remember this formula for 2 sets, okay? Because I saw all the questions you got in the counting round, and even the 3 rounds is based on these based on 2 sets, not 3 sets. Okay? Okay, before ending, let's try another example. This time, okay, let's talk about another class again. Or let's go to the jungle. Okay, 50 animals we don't know. Let's call the lions. 50 lions. Not lions, are vegetarian animal. 50 cows. Monkeys, they are also vegetarian. Monkeys, 50 monkeys. Okay. They like banana. Okay. Yeah, banana. Let's call it B. And 30 monkeys, they like apple. Okay. And 20 monkeys, they like both apple and banana. So both means, when I say both, it means intersection A intersection B. Now you have to find how many monkeys are there in the jungle. And other than these two, banana and apple, there are no other monkey who likes some other fruit. Okay, so there are only two types of monkeys: eating banana or apple or both. Okay, there is no third type of monkey. Just assume that. So how can I find total number of monkeys? This is size of A. Again, I will use this formula. A union B will be the number of monkeys in the jungle. Yes or no? Because I told you, either they eat banana or apple or both. So only three things are given. If three things are given, then I have to find A union B. So A union B will be number of monkeys in A, number of monkeys in this group, and minus A intersection B. So what is A? A is 50, B is 30, and A intersection B is 20. This is 80 minus 20, 60. There are 60 monkeys in the jungle. So we talked about the concept, and then we talked about some of the examples. I think this should be clear now. So how many things we talked? Set, universal set, then union, intersection, and then inclusion and exclusion. Okay, one thing we forgot, complement. Okay, this is very simple. It will not take. Complement. So complement of any set is the elements which are not present in that set. Let's say our universal set is all the numbers up to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A is 3, 5, 7, 8, 9. Okay, so complement of A will be all the, and it's written like this, either A, C, this symbol, or like this. You can use anything up here. Okay, I prefer this symbol. So, or if you want to use this, you can use this one. So this will be all the elements from U which are not in A. Can you tell me which all elements are? Look at the board. Which all elements are there in U which are not present in A? It's 1, 2, 3 is there. So no. 4, yes. 5 is there. 6, 7, 8, 9 is there. And 10. This is complement of A. So from the universal set and the given set, we can find the complement of that particular set. Okay. So A will have all the elements which are, sorry, A complement will have all the elements which are not present in A. Okay. if A has all the elements, let's say A is also A also has all the elements like 1 to 10. What will be the complement of A if it also has all the elements? Empty, yes, it will have empty set. So if it has all the elements, you can say, okay, A is, let's say this here, for example. If A is, I will use this symbol to say it has all the elements from U. So in that case, you can say complement of A is empty set, or you can write it like this. It's easy. I think we covered all the basic stuff that you should know, and then I'm going to make some quizzes based on it, and then we'll be done. Okay?